Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes way. Don't delay and enroll now.
Geeks learning together.
Hello, guys, and welcome back to this amazing channel, Geeks for Geeks Practice. Guys, because of some issues, I will not be present today. My video is not present in the stream because I'm not at my place, or you can see a perfect location. So, first of all, please let me know if I'm clearly audible to you all, not visible today, just for today. Am I clearly audible to you all? Hi, Rishit. Hi, Madhur. Hi. Yeah, okay, so great. I can see I'm audible. Great, guys. So let's start today's problem, today's POD. Guys, you can see the POD for today is max points, and it is a quite difficult problem because it is based on dynamic programming. It's a problem based on ranges. So basically, from the given ranges, you have to choose any two ranges such that you have to choose any two ranges such that their sum, the sum of points are maximum is maximum. Okay. So I hope that you guys are already familiar with the problem as you have solved it today. I'm hoping that okay. So now let's see how we can solve this particular problem, how we can do this particular problem today's class. So guys, first of all, whenever we get this ranges problem, so in most of the cases we have to sort it. So that is what we'll do here also. So if you will see, if I'll simply copy this particular part of the test case, the second test case, because it has five values, so I will prefer that one only. So you can see it here. This is the test case that we are having. Okay. So guys, if I will sort it, the sorting will done on the basis of the first value. Okay, the first value of this range. So you will see after sorting the linked list, like it will become like this. It will become like 1, comma 3, comma 4. Then it will be 2, comma 3, comma 5. Then it will be 2, comma 8, comma 10. Then it will be 3, comma 4, comma 2. And then 5, comma 8, comma 9. So I will first sort it. So what they want that you have to choose two intervals such that they should not interact each other. So the values of the two interval can be basically like it can be like this. It can be like if you are taking one interval from 2 to 5, then you can take your second interval from 5 to 9, but not before 5. Sorry, one mistake. You can see this interval is from 1 to 3. Like this is the interval, and this is the coins present. Okay. So let's say that you are taking your first interval from 1 to 3. So you can take your second interval from 3 onwards. But you cannot take your second interval from 2 onwards. Okay. That is called intersect. That's the first thing that you have to consider here. I hope it is fine. Okay. Great. Now what we will do here is that we will be guys checking for each and every interval, and from that particular interval, either I will consider that particular interval or I will skip it. So here also the case will be like skip and non-skip case. The case will be something like take and not take. It will be a quite a DP problem. So first of all, we will write the recursive approach, then we will memorize that recursive approach. Okay, that is what we are going to do. See, what we are doing here is, okay, so you can see here what we're having is that this is the thing that we're having. What I will do is, first of all, I will solve this range. So guys, first of all, please tell me if the problem statement is clear to everyone. Please tell if the problem statement is completely clear. Hmm? Okay. Now see guys what we will do. See what we will do here. So guys, now I will write a recursive function here. So guys, recursive function will have two things. Recursive function will have two things. First thing that it will have is the first thing that it will have will be the index where you are currently. So obviously we'll start on a zero index. Okay. And guys, second thing that you will have is the second thing that you will have will be number of I can say ranges that you have taken. So I'm assuming it at D. I'm assuming it as D. But I have currently taken D number of ranges. Currently, I have taken D number of ranges because how many ranges we want? We want two ranges. If you remember, we want two ranges. Right? You have to take two ranges from here. Okay, such that the sum of that should be maximum. That is what we want, and they should also be not intersecting. So I will have my index I where we are and this D. Apart from this, guys, what I will have here this vector. That's all. Okay. Now, guys, see what will be the base cases. So, because it's a recursive function, first of all, we write the base cases. So, guys, the base cases will be till when this I will work. So, guys, this I will basically work. This I will basically work till it is less than like within this range. So, whenever this I will become greater than equal to ranges dot length, means ranges of sides basically, means you have to return 0 means that you're because what this function will return, this function will return the maximum sum. So currently I'm saying return 0. Okay, now what will happen is that if the value of these gray is equal to 2, okay, because we want just two ranges, got it, we just want two ranges. So whenever my D will become 2 means I've got my ranges, then also I will stop. Now let's see what we will do. The next case, see what we will do. So guys, let's say that currently we are at index number I. Okay, we are index number I. Means I will consider the value at the index number I. I have considered the value at that index number I. Okay. So guys, there are two cases. One is the take case and another is the not take case. One is the take case, another is the not take case. So let's say guys, that my I is here. So I am saying either consider this in my answer or move to the next case. Either take this in my answer or move to the next case. So guys, first of all, we always take our not take case. So my not take case will be, guys, that I am not taking that particular range and I'm simply moving to the I plus 1, means the next range. Is this case clear to everyone? The not take case is clear. We are not taking that particular I and I'm moving to the next I. Got it. Now comes to the take case. Now guys, take case means I am considering that particular I. But I have to check that with that particular I, which next index should I take? What should be the next index I that I should take? Okay, if I am considering that particular I. So guys, let's say I'm saying that I am at index number I. I am at here. Okay, I'm here. Great. So guys, what we will do, I will check this value. Like let's say if I'm index number I, so I will take the value of ranges I 1. Like this is 0, 1, 2. So I will take this value, the end I. I will take the end pointer, the end index of that particular range. Why I am considering the end index? I am considering the end index, guys, because the next index, the next value should be a value whose starting index should be greater than equal to this next index. That is what is given to here. The next value should be a value whose starting index should be greater than equal to this value. Am I right? Am I right? And for that particular thing, guys, we will implement the binary search. Why binary search? There's a reason for that. Because if you will have a linear search approach, you will check for this one, then this one, then this one. So it will be a very difficult way. How you will find the value which is just greater than. But if you will apply binary search approach, got it? Exactly. Next should be non-overlapping. So we will use a binary search approach to take a range whose starting index is greater than equal to, or I can say lower bound. What is lower bound? Lower bound is greater than equal to. So guys, what I will take here, I will take here the new index. So let's take here a value. Let's say I will say it new index. And initially I'm assuming that new index as, let's say, a very large value. Okay. Now I will take two things here. Like the two things will be nothing but the ranges of the binary search. So if we are at index number I, so my binary search means my next index should be from I plus 1 to the end of the array. From I plus 1 to the end of the array. Okay. So my L will be I plus 1 and my R will be N minus 1. N means ranges dot size minus 1. Okay. That is what I will have. Now, guys, simply the binary search while L is less than equal to R, I will write. Okay. Now I'll find the mid. Okay. What I want that the first value at that mid. First means value at index number 0. This is the first value, no? The first value of that mid, the first value of that new index should be greater than equal to, the second value, means the end value of your current index I, so that it should not merge. And if it is greater, that means this can be your new I, means new index. And then again we'll check for a lesser one, because we want the nearest one. Now we will not move forward, and else I will move for the next. This is how we are writing the binary search. Now, guys, I have taken this. Now the take case will be, guys, the take case is saying that, it is simply saying that you have taken the current index. See, it means that the current index that you have taken is I. The current index that you have taken is I. So you will take the coin of that I. Coin means the second, like 0, 1, 2, the second wala, this third value of the range is coin. So means ranges I2. So take case will be ranges I2 plus equal to भी होगा नहीं, equal to नहीं होगा मतलब, because like equal to is not required. I'm not getting, कहाँ पर बोल रहे हो? I'm not getting where are you saying, on which line मतलब, on which line? यही होगा यार, because I want, see, the next range should be either greater or equal. The next line should be either greater or equal. It should not be just equal. Okay, it should be either greater or equal to the current range, so that it should not interest. Okay, got it or not? So now we are taking a take case. Take case means take the coin of that particular index and then call your recursion for the new index with d plus 1. D plus 1 simply represents that you have taken a range. Okay, because D represents a number of ranges. And then at the last, your answer will be, I will say like this, your answer will be maximum of take and not take. And then simply return your answer. That's all. And here you will simply call this recursive function for 0, 0, ranges. Why? Because guys, initially the value of I will also be 0 and D will also be 0, means I have not taken any range till now. But guys, you will see this approach will take order of 2 to the power n time complex, as it is a uh, as it is a recursive solution. So I will convert this recursive solution into a DP solution, memorize it. So you can see in every DP we have two variables, I and J. Two things are changing. Either the value of I is changing and the value of J is changing. Means you will have a DP array or a vector of these two things. So we'll take here a DP vector also. Let's take it as a DP vector. It will be a 2D vector just like this. It will be a 2D vector. Okay, DP. The size of the vector will be n, and for the corner case, I will take it as, let's say, n plus 1. Okay, and similarly, the vector, this will be of size 2. Why 2? Because you can see the value of D will range from 0 and 2 only. D will be either 0 or 1. Whenever it will become 2, it will return. Okay, great. Now, guys, I'm initially initializing it by -1. For those who do DP, they know this thing. Okay. Now I will pass this DP vector. Okay. In this recursive function. Okay. Now, guys, what we do in DP? It's a very simple. Let's see how we can. It's not actually backtracking. This is okay. It's not actually backtracking. Now, guys, very simple. The very simple is that whenever we have to memorize a recursive solution, simply before taking the case, first check if the value of that I and D is not equal to -1, means it is already calculated. Simply return its value. And here also, when you are calculating the value, just initialize it with the DP vector. That's how you memorize a solution. Okay, one more thing. In the recursion calls, you have to also add that DP thing. You have to pass that also. Okay. So great. Let's submit it. So you can see, guys, that we have got, okay, here also we're having some wait. What's the problem? They are saying some segmentation fault is there. Not getting what segmentation fault should be there. Okay, again the same case, it's failed. Okay, I think when my new will become, it should also be like greater than equal to 2. D can also, if like whenever D is greater than equal to, then also it will stop. Actually, even I cannot check this thing. Uh, Not getting what's the exactly wrong I have done here. L plus or minus L by 2. Let me check all the cases that we can have. Yeah, I'm just checking that what's the problem we're having here. Okay, at this number of test case. I'm not getting like what's the problem here? Uh, okay, we have taken a D, we have taken this thing, we have taken ranges, we have taken a DP, so we have checked if DP is there. Then we're taking the not take case. After having the not take case, we're again having the binary search, the mid. If the value is fine, we're having it. After that, I'm taking the take case. And in the take case, we are adding the values, we are calling for that. Then at the last, we have the maximum of take and not take, and we are returning the value. Yeah, like it's completely fine. Not getting like yeah, like we can print the values, but actually this is a very large case. Like for this case, even we cannot debug. You can see this is a very large case. Is it? I don't think that we can debug for this particular case. Uh, it should be like segmentation fault usually comes when we are trying to access any like out of bound. Usually it's done. Should we take long here? Like maybe it's because they will take long. But but when we are returning, it should be an end. So like why I'm not? Yeah, it's not. I've done more than 4 or 5 wrong submissions. Uh, uh, I don't think it should be wrong. Like it's running completely fine. Yeah, at 1110 test cases, the last 6 test cases. DP of ID is not equal to -1. Return DP of ID. Got it. Then we are having first the recursion not take case with I plus 1. Then we are having a new value L and R while L is less than equal to R mid ranges. It is checked. Okay. And new I is equal to mid. R is equal to mid minus 1. R is equal to mid plus 1. Uh, got it. Got it. Ranges I new I is taken here and D is increased by 1. That's also completely fine. And then we have returned the value of that DP. Everything is like seems fine. Everything seems great. Okay. Yeah, like I don't think it should be out of bound by the way. Like 2 into n should like for 2 into n also, I don't think that it will go that much. Yeah, for 2 into n also it's not like running. And even I have increased that also, the second case. Mm, am I taking the vector correctly? Yeah, that's taken correctly. The sorting is done correctly. Uh, if you want, I cannot take this thing. I can directly take the take and not take case. But that will also not, I don't think it should wait. Let me add it after it. Let's take it as answer, and here I will take the maximum of answer and this thing. Okay, still the problem is here only. Let me see what they are doing in comments. Okay, let me check. Uh, just give me 1 minute. Let me check the official solution for it. I have to check it today. Sorry. Uh, Guys, by the way, official solution is also exactly same, and I don't know why this thing is happening here. Let me submit the official solution. Let me submit the official solution of this problem. Uh, okay. Let me first submit it with the official solution that they are doing, and it's also something similar. If this will run, if this will run, so this is also exactly same. Okay, guys, you can see this one was exactly same. This problem is exactly same what we were doing. By the way, as you were saying, let me first refresh the code. Mine, ours is giving wrong, but if you can see, I have made a submission here. This one, it got the correct. You can see this one. The thing is exactly same, and it's giving the right out. Okay, so like you can check out this one. The thing is exactly same. Maybe there's some problem with the ID or anything. Okay, I will share this particular code with you all. Okay, you all can check it out. And this logic is also exactly same what I have done. Okay, let me share the code with you all. Uh, Fine. Let me share the code. Yeah. So guys, this is the code, and the thing is exactly same what I have done. Fine. So I hope that you have got this particular solution that we are doing here. Okay. I hope you have got it. This is how we basically implemented. We are first, just the thing is that we are taking an index I. Okay. And then we're checking for the next index I plus one. That whether it is fine or not. If it is fine, we can take it, we are considering it, and we are taking it recursively. And then we have memoized the solution. Okay. So I hope guys do okay. Okay, great. Okay, so great guys. Thanks for today's class. I hope it was helpful. Let's meet again next video. Till then, thank you. Happy coding. Bye bye. जीएफजी कर लो, हो जाएगा। थैंक यू।